right, let's start by talking about what USD actually is. So USD stands for Universal Scene Description, and you can learn a lot more about this at openusd.org. I highly recommend going through some of the information there. It will be very useful to understand. So USD was developed by Pixar. It is open source, which is why it's great. It's being used everywhere now because of that. It's universal, so it's not dependent on any specific DCC. It is a format on its own. It has both a data encoding format and a data interchange format. So it has a description, but it can also encode the data as well. It's meant to be very performant. One of the really important things with USD is the referencing and layering system for creating assets and shots. USD understands encapsulation and it understands relative paths, so you can make an asset and package it with all of the relevant materials that come with it and the texture maps and reference that in other parts of your workflows. It's meant for collaborative workflows, and that's really important. So somebody can be working on, let's say, the animation for a scene while another artist is working on the lighting and just continuing to receive updates about what the animators are doing without it ruining their scene and without them having to go through re-import processes and stuff like that. They can just keep working and, update as necessary, and everybody works in their own pools. And very importantly, you're not polluting other people's data. And USD is meant to be non-destructive. So if you're working correctly here, you can just layer your changes on top of other people's changes without going and ruining their stuff. So a good example would be you have a set that's been configured by a layout department or by a modeler, and now you import it into your scene and you need to move some things in that set around. Well, rather than just altering the original set, you can layer your changes on top as a file. You can send that out as a reference that other people can then grab and bring in, and the original structure of that scene composition is preserved if you're doing this correctly. Now, important to note, USD is not a render engine, right? All it is scene composition and scene description. So it describes how the scenes are put together, and it has the schemas that are used by render engines that will render it, but USD itself does not do any rendering. We're going to do a little bit of a USD glossary right now. Some of it's going to be confusing, but it'll make a bit more sense as we get into it and do a few things here. So let's first start out with a couple of the main pieces of information that are part of USD. And these are these main things that you'll need to know about. So the first is the stage. So the stage is basically that final result of the USD composition of a scene or a USD file. You can basically just think about it as the place where everything gets put together, and it is that final bit of the puzzle. Now, you can have, entire stages referenced into other stages and stuff like that, but just kind of remember that it's going to be the final results, that final composition. The thing you'll be using the most are primitives. Now, don't confuse this with Houdini primitives. It's not a piece of geometry. A primitive in USD, it's just a building block. It's just a piece of data. It can be meshes. They can be things that are attached to geometry. It can be shaders. It can be materials. All of these different things are essentially just atomic building blocks, and those are referred to as primitives in USD. Attributes are a lot like Houdini's attributes, and they're stored on USD primitives. They have various data types, point positions, normals, velocity, etc. So when you start looking at the primitives there, you'll see that they have attributes. Now, there are special kind of attributes called prim variables, or primvars for short. All that means is that they're namespaced, right? So they're attributes just like any other attribute, but they live in this namespace called primvars, and they're mostly used for rendering and shading. I think part of the reason that they are namespaced like this is so that they can be quickly and easily found for rendering and shading. Another thing to know about are relationships. So they're different than attributes and prim variables. They actually describe how different primitives relate to each other. One example, and one place you'll see this in quite often, is material bindings. That's a relationship. A material is one thing, a piece of geometry is another thing, and how those two pieces relate to each other is a relationship. Layers is a big part of USD. And what layers are a lot like Photoshop layers. You can think about them like stacking information on top of each other, stacking what are called opinions and decisions on top of each other so that you reach a final composition. So, let's say artist number one creates an asset and that asset has the color red on it. And then artist number two works on the next stage of development in this pipeline, and for their shot, that object now needs to be purple instead. So they layer their opinion or their decision on top. Now the layer says this is purple, and the very final thing that we see once we get to rendering is the layering of all those different opinions on top of each other. Composition arcs are the operators that allow USD to create rich compositions of many layers containing mixes of base, scene descriptions, and overrides. Okay, that's a mouthful. What exactly does that mean? It basically means that when USD is performing operation on data that already exists, for instance, referencing or changing existing geometry, it's doing a composition arc. Okay? There's lots of different ways of changing what's already there, and we're going to look at some of that. Composition arcs, all these things, they have strengths, and this is part of USD, is that we have these various different composition arcs, and they actually have strength ordering, which means that they will override what happens either below them or above them. But stronger ones will obviously win out in this battle of opinions. So there's this little acronym to remember. It's LIVERPs, and this is the strength ordering. So it means the local opinions are going to be stronger than anything else. Then we have inherent, variants, references, payloads, and specializes. We will cover what each of these means, and we'll show examples of how they are used. But for now, mostly just remember this acronym, and it will help save a lot of problems later on. Now, as part of the glossary, we'll just talk about what these composition archetypes are, and we'll actually get to see them used coming up very soon. But for now, let's just do a little glossary explanation of what this is. So local are opinions written into the active layer. So you're currently working, that's your working session. That's going to be the strongest thing that's happening. Inherits, what inherits are is almost like coding, where you have a object-oriented kind of system, and you have a class, and the class has a definition inside of what this class can do, and every time you use an instance of that class, it's going to inherit anything that's part of that base class. So for instance, if you had a class called car, any car that you put in the scene is going to understand the basic things of a car. A car has wheels, a car has a steering wheel, a car has an engine, etc. If you change anything inside that base class where things are inheriting from, it's going to flow through into your composition. This will make a lot more sense when we see it in practice. It's a bit confusing to talk about just as an abstract glossary sense. Variants are a much easier thing to understand. They're just pre-configured versions of an asset. So think about that like a catalog. You can have a shirt, and then the user will have an actual exposed variant properties selector that says, okay, oh, it looks like I have a catalog that says this shirt can be red, or it can be blue, or it can be large, or it can be small. So they're just kind of pre-configured versions of an asset. References are ways that USD files are imported into a scene graph. One thing with references is that they can be inserted into arbitrary places in the graph. They can be renamed. They're kind of your basic building blocks of putting objects together to make groups and assemblies and larger components. Payloads are special kinds of references. It's a very minimal kind of a reference. Essentially, it's just a description of what will be coming in at some point. So it has a list of like, okay, here are the things that I'm going to reference in, and here's the bounding box information for that. And it might have a few other, bits and pieces of information in there. But essentially, it's a very, very small version of what will come in. And the other thing with payloads is that when you're working with USD, one way that you can optimize your viewport performance is to just unload anything that is a payload. So essentially, you only see the bounding boxes, and you can turn things on one by one. So it can make a very heavy scene actually workable when you need it to be. Specializes are very much like inherents, but they have the weakest opinion strength. They're usually used in assets when you're making materials and you want to basically start with a kind of master material that is missing some of the finesse in there, let's say. It's a very basic version of the material, and then you want to continue to work on that and actually like make it a bit more special for the assets in particular. It's not frequently used, at least in my workflow, but we will get into an example of how it works in USD as well. It's important to note the various file formats that are available to you with USD. So we have 4 different flavors of USD. We have the USDC, which stands for a crate file. Now, these are binary files, and what you would typically use these for is encoding geometry. So it's very fast for reading into scene graphs, and it's good for very large data sets, but however, it's not human readable anymore at that point. We have USDA, which are ASCII file formats, and these are human readable. It can be good for debugging what's going on with your files and checking your USD scenes. And it's good for very, very simple sparse edits. Maybe you're altering a transform, or you're just sublayering a couple, layers in, or bringing in a few references and not doing much. Then a USDA file could be very useful for you. USD as a file format on its own is interesting because it can go either way. Depending on your encoding options, it can either be a binary file or it can be ASCII without changing the file format name. So it can keep the extension name, which is great because it doesn't break any references, but you can change exactly how the data is written into that file with some encoding options. And then finally, a lot of people may have heard of USDZs, and these are just compiled USD stages. So it's like a zipped up version of a flattened USD hierarchy. It has all the geo in there, it has the materials, it has the texture maps, and everything is just zipped up into one package. And typically you're not using this in production. This is more like a delivery. Like you've created an asset, you need to deliver it to somebody with all of the goodies contained in one file. That's what a USDZ would be used for. Now, on the Houdini end, we want to talk about a few different things here because there's a lot of terminology and some of it's a little bit confusing. So let's get through some of this. The main things that I wanted to talk about here are Solaris, LOPS, Hydra, Karma, a lot of buzzwords and things that might be confusing understanding what exactly is what. Okay, so first let's talk about Solaris. And Solaris is just the umbrella name for Houdini's scene building, look development, and Karma tools, right, that are based on USD. So it's the umbrella for everything that is USD related. Okay, that's Solaris. LOPS actually stands for Lighting Operators. And I don't love that name because LOPS context is actually more for USD composition. It does a lot more than lighting. And I think it's meant to be doing a lot more than lighting. So it's a weird naming convention, but we'll just go with that. Okay, but that's where you build all your USD scenes, and that's where you do USD composition, and yes, it's where you light and it's where you render. Now, Hydra is not a Houdini thing, but you're going to hear that word Hydra a lot in many different contexts. And essentially what Hydra is it's a framework to transport scene graph data to the renderers. So it's the interface between the USD file and the render engine. It draws the scene. There is a quote here that comes from the Houdini documentation, and this is probably the best way of understanding it, and I'm just going to read it. So USD defines an API, which is called Hydra, for generating an image from a USD scene at a certain point in time. As long as a program, such as Houdini or USD View or a renderer implements this API, it can be used to display or render a USD scene, right? A piece of software that implements this API is called a render delegate. So you're going to hear the word render delegate a lot. A render delegate is basically a thing, a piece of software that can draw the scene through Hydra. It implements the Hydra API, and then, behind the scenes, it's doing whatever it needs to do to actually create the pixels on the screen. So Arnold has a Hydra delegate, Redshift has a Hydra delegate, Karma is a Hydra delegate. You'll hear that word a lot. And now Karma is Houdini's native render engine. Karma comes in two flavors. We've got CPU and we have XPU version. Karma uses USD as its scene description, right? So this is kind of important to note, because if you haven't been using Karma, you've been using, Mantra the old school way, it was using IFD files. That's not a thing here. We ingest USD and we render USD. So at this point, anything that you're rendering in Houdini that you want to render in Karma, it must be converted into USD, which is part of the reason why I'm doing this course, because it's going to be really helpful for people wanting to understand what's happening when they render a scene.